Welcome back to the Explainer. So, get this. What if an AI could learn to play a game, not by grinding through it millions of times, but by actually thinking about it? Today, we're diving into a new kind of AI that does exactly that. All right, so here's how we're going to break this down. First, we'll talk about the whole black box problem with AI today. Then, we'll get into how AI usually learns to play games, before introducing this wild new idea, I think, therefore I play. We'll see how its play and reflect cycle works, put it to the test, and then we'll talk about why this is so much bigger than just winning games. You've probably heard about these superhuman AIs like AlphaGo that can beat the best players in the world at super complex games. It's amazing, for sure. But here's the thing, they're basically black boxes. They learn by crunching a mind-boggling amount of data, and all that knowledge gets buried deep inside a neural network. They become champions, yeah, but they have no way of telling us how or why they made a brilliant move. And that right there is the big question, isn't it? It's really the core of what we're talking about today. What if we could build an AI that learns a bit more like a human? You know, not just through endless repetition, but through actual reasoning and reflection. So you've got these two totally different ways of thinking about it. On the left, that's the old way. Just throw billions of game frames at it until it learns something. But all that knowledge is locked up, it's hidden. On the right, you have this new idea, learning through reasoning and planning. It learns from just a handful of games and, this is the crucial part, the knowledge it builds is an explicit model. You can actually read it and understand it. Okay, so to really get why this new agent is such a big deal, we gotta quickly look at how things are usually done. Let's cover the main ways AIs are currently built to play games. It's kind of like a story in 3 parts. First, you have your conventional reinforcement learning. That's the black box we talked about. It just learns from rewards, trial and error, super slow. Then you've got these powerful language models that can reason about a game right out of the box, which is cool, but they're static. They can't learn from their mistakes. And that brings us to this third paradigm, Cogito, Ergo Ludo. It's the best of both worlds. It reasons, but it also learns, building and improving a knowledge base that we can actually read after every single game. And this new way of doing things? Well, it's all wrapped up in a pretty cool new agent they've developed, and its name is CEL. The name is just perfect, right? It's a play on that famous philosophical line, I think, therefore I am. But here it's, I think, therefore I play. It perfectly sums up the whole idea. This agent starts with absolutely nothing, a total blank slate, and it builds its entire understanding of the world just by thinking about what it does. So, how does it actually do that? How does it build its own brain from scratch? Well, it all comes down to a really simple but incredibly powerful 2-part cycle. It's all about this 2-step dance. First, it plays. It's in the game, making moves based on what it thinks it knows. Then, after the game is over, and this is the magic part, it reflects. It sits back and analyzes everything that happened, win or lose, so it can learn and get smarter for the next round. And that reflection phase has 2 really cool parts. The first one is called rule induction. The agent is basically being a detective. It looks at the entire game replay and tries to figure out the basic laws of physics for this little world. It's literally writing its own instructional manual from scratch, trying to understand how does this world work. And then there's the second part, which is maybe even cooler. It creates a playbook. This isn't about the rules anymore. This is about strategy. The agent looks at what worked and what didn't and boils it all down into a high-level guide on how to actually win. It's figuring out the how to win part of the equation. Okay, this all sounds fantastic in theory, but, the proof is in the pudding. Does this thinking machine actually work? Can it win? So they tested it on some classic logic games, but they made it really tough. These games have what's called sparse rewards. That means the AI gets 0 feedback during the game. No good move or bad move hints, nothing. The only feedback it gets is at the very, very end, a single you won or you lost. That's all it has to learn from. And the results are just fascinating. Take a look at this. This shows the peak performance in Minesweeper. On the left, that's an AI that was literally handed the rulebook from the start. On the right, that's Cell, our agent, which started knowing absolutely nothing. And look, it ended up with more than double the success rate. The play and reflect cycle didn't just help it learn the rules, it made it a better player. 54%. That's right, the agent that had to teach itself how to play from scratch completely outperformed the one that had the rules explained to it. That's wild. And this is where it gets really mind-blowing. Because its knowledge is written in plain English, we can just open up its brain and read what it's learned. This is a direct quote from the rulebook it wrote for itself about Minesweeper. It figured that out, a core rule of the game, all on its own. And it's not just rules, remember? We can also peek into its strategic playbook. And here you can see it developing actual wisdom. Avoid moving to edge or corner cells early. That's not a rule, that's a strategy, a piece of advice an experienced player would give you. It's distilling experience into wisdom. Okay, so it's good at Minesweeper. Big deal, right? Well, actually, yeah, it is a huge deal, because the real importance here goes way beyond just winning a few puzzle games. This is the question you always have to ask with AI. Is it actually learning and understanding, or is it just memorizing the patterns it's seen before? Is Cell just getting good at the specific Minesweeper boards it's played, or does it get Minesweeper? And the data here is just, wow. It speaks for itself. Look at that top row. An agent trained only on Minesweeper still hits a 50% success rate on brand new layouts it's never seen. But here's the kicker. Take that same agent, drop it into a totally different game called Frozen Lake, and it scores a 97% success rate. It's not just learning a game, it's transferring its ability to learn to a new problem. So what this all boils down to is that CL isn't just learning a set of rules for one specific game. It's learning something much more fundamental. It's learning the abstract skill of how to reason about a new situation, how to make a plan, and then how to act on it. And that is why this is such a potential game changer. This is a real step away from the black box. Because we can read its thoughts, that rulebook and playbook, we get transparent and auditable decision-making. We can finally start to build agents that aren't just powerful, but that we can actually understand and maybe even trust. And that just leaves us with one last massive question to think about. We just saw an AI discover the hidden rules of a game, starting from nothing. If it can do that, what other hidden rules about our own world could an agent like this one day discover, all on its own?